Good morning, everybody. Welcome back to lecture number 29. Today it's going to be a very fast lecture because we are late, okay? So here is some notations fixed. I fixed some notations. In revision 3, we use different notations for some components. For example, let's start with synchronous speed n sub sync. Now I'm calling it n sub sync. Previously it was in the previous video, it was n sub s. So I'm going to use n sub sync so that we don't confuse ourselves. Fe is electrical frequency. P is number of poles. So n sync is the mechanical synchronous speed. Mechanical synchronous speed. Why we call it mechanical? Because it's an actual movement that you can measure it by the tachometer. Synchronous means it is in sync with the frequency. It means what? It is in sync with the 60 Hertz. Speed in RPM. Fe is a supply, 60, 50. Or if you have an inverter, you might have higher frequency to control the speed of the induction machine. Okay? And remember, for 4-pole machine, 120 times 60 over 4. That's what? 1800 RPM. 2-pole, 3600. So if you have more poles, the machines will be smaller from mechanical perspective. Mechanical shaft will be smaller. The other component is the slip, which is delta n over n sync, or delta omega over omega sync, which is n sync minus nm. What is nm? Nm is the actual mechanical shaft speed in RPM, not synchronous, not in sync مع 60. Okay? This is usually slip minus, يعني if it's 3600, maybe it's 3580 or 3590, depending on the slip. 2%, 3%. An omega sync is mechanical, angular, synchronous shaft speed in radians per second. هي نفس ال n sync, but you use this formula. Get it? Yes. This formula is applicable globally. Omega m equal to pi nm over 60, or omega sync equal to pi over 60 times n sync. Both of them, they have to be the same quantity. You cannot have omega sync and nm. The last component is omega m, which is same as nm, mechanical, angular, actual shaft speed in radian per second. Clear? Yes. Are the notations now clear? So slip, from standstill, the slip is 1. Okay? So omega nm and omega m at standstill equal to كم؟ 0. standstill ايش معناه؟ من السكون. والأوميجا m nm is not in sync. هذه standstill 0. It will increase until it reaches the synchronous, but there is no induced torque, so it will go a little bit smaller by the slip, and then it will stay there. N sync with omega sync has to do with the electric supply and number of poles. Nm has to do with the slip in relationship with the N sync. And last lecture we did this example. Do you remember this example? Yes. Where we calculated Nm from N sync, which is 1 minus slip times N sync, which is 3528 for a 2% slip. So the more slip, the slower Nm. One important quantity that I want to introduce today, and I'm going to be a bit fast in the lecture today. Rotor electrical frequency, F sub R. Do you remember the squirrel cage? Yes. It has bars and 2 end rings. How many end rings? 2. From standstill, the slip is what? 1. 1 kF because stand still implies Nm equals 0 RPM. This implies slip is what? N sync minus Nm over N sync, which is 1. N sync over N sync minus 0. هذا معنى stand still, you can translate على Nm. Now, at stand still, what is S1? معناته ان الروتر current frequency equals to stator supply frequency. الكرنت اللي يمشي في البار والاند رينج at stand still it's 60 Hz or 50 Hz. Then the faster the machine slip, what will happen to slip?
Decrease.
It will decrease. It means the frequency will decrease. If we reach synchronous speed, which we will never have to, we will never reach, the frequency will be 0. The frequency will be 0. So there is current flowing inside the rotor bars and end rings with varying electric frequency of Fr in Hertz when speed changes. إيش معنى speed changes? Slip changes. Okay? So there is a question in the exam. Maybe describe the frequency of the current in the bars, rotor bars. You say from standstill they would start with supply frequency. As the slip changes, we're using this formula, we can calculate the rotor frequency. The stator frequency, is it fixed or varying?
Fixed.
Fixed. Rotor?
Varying.
We talked about an equivalent circuit. You remember all of these discussions, you can watch a YouTube video. And you remember the mathematical trick of R2 prime and R2 prime over S1 minus S. If we add both of them, they will be equal to what? R2 prime over S. Do it. R2 prime plus R2 prime over S minus R2 prime, S over S cancel. This minus will cancel with that, then you'll have R2 prime over S. Why we do this trick? To resemble this in the transformation circuit, transformer circuit. This is the load, this is the secondary part of the transformer, this is the primary part of the transformer. And find that the circuit is originally separated. We call it galvanic isolation. It's physically separated by the air gap, اللي هو الهواء. Can the air gap be 0? If the air gap is 0, what will happen? It will not rotate. The rotor will be stuck in the stator. So always there is an air gap. في الدائرة 5 milli, 6 milli, maybe 3 milli, maybe 1.5 milli. But if you make the air gap too big, the power that flows to the air gap will be smaller. Okay? So let's do some example and calculators, please. Example 2, part A. 208 volt. What is 208 volt? It's line to line. Why it's line to line? Because the induction machine is a 3-phase. Is the induction machine 3-phase or single phase?
3-phase.
3-phase. There is induction machine in single phase, but it has electronic circuit that would make it working. We're not going to cover it in this course, but you can read about it in the book. Why we have line to line? Because for every 3-phase we love the line to line. For DC machine, do we have line to line? No. So this is usually given in line to line. 10 horsepower. Convert 10 horsepower to kilowatt. Multiply by 746 watt. So this will be what? 7.46 kilowatt. This is the output power. Rated. ايش معنى rated? Full load. ايش معنى full load? By design. لا يجي احد يقول الباور هذه هي الانبوت باور. هذه زي السيارات. Is it the input power of the car or the output power of the car? زي السيارات. It's a motor, think of it as a car. So this is not the input power. The input power you get it from the volt or current. The input voltage will power factor or current. 4 poles, 60 hertz, Y connected, slip of 0.05. What is the synchronous speed? ايش هي synchronous speed? N sync. What's the equation? 120 times 60 over 4, which is 1800 RPM. Clear? Part B. What is the rotor speed of this motor at rated load? Rotor speed, is it mechanical speed or electric frequency? يسأل عنه. Mechanical speed. So it is what? N sub M, which is N sync, 1 minus S, which is 0.95 times 1800, which is what? Calculators.
1710.
Who doesn't have a calculator?
1710.
You share it. We have to do calculator. We have circuit calculation today. I don't want to be late. 1710 RPM. C. What is the rotor frequency of this motor? Easy. FR equal SFE, which is 3 Hertz. 5% من 60 3 Hertz. Question D. What is the shaft torque? You do shaft torque is from output power is torque of the shaft times omega m. What is the output power? 7.46 kilowatt. Equal shaft. Now what is omega m? 1710 times 2 pi over 60. So what is the output torque? Calculators.
41.7.
You're right. What's the unit of the torque? Newton times meter. There is a simple typo in the book. I'm using book number 2, not book number 1 for induction. This is the typo. I want you to fix it, please. This is 1 minus 0.05. 1 minus slip. Okay? Also, he is showing you another formula to get the shaft torque using pound times feet. If you want to do your masters in the UK, you might deal with this, I don't know. But you can use this formula to get the torque in pound times feet, which is 5252 P in horsepower over N. But what matters is anything above. Anything below not required, but this is for your knowledge. This is the VIP. So what is this VIP? 3-phase, 460. What is 460? Line to line. What does it mean? It means what is this voltage? 460 over square root of 3 angle 0. Take it usually as a reference. This is AC source. Is this AC or DC? AC. What is R1 and X1? They are given. R1.641, X1. What is RM and XM? RM, is it given? No. So assume it's infinity.
RM?
Yes. Usually it's a big number. 100. 100 compared to 0.6 is a very big number. And when we do 100 parallel مع small, it will go away. The motor operates at ولحظة عندنا circuit 1 or circuit 2? Circuit 1. We have X2 prime, R2 prime, R2 S. Do you remember I told you these two you can treat them as one resistor, which is R2 prime over S? For this example, treat them as R2 prime over S. But keep this original circuit. Why? Because later when we change the slip, what will happen? Everything will change. So this is the circuit that you use, but these two, if you add them, it's R2 prime over S. So, to calculate the well, we can say, what is motor speed in RPM? Nm equal 1 minus S times N sync. What is N sync? 120 times 60 over 4. So what is Nm? 1 minus 2.2 over 100 times, and put them in million. What's the answer? What is your calculator?
1760.
If you don't want to do the calculator, you're free to leave the class. Wallah. I don't see it.
70.4.
Do something else if you don't want to do the calculator. Wallah. Go sleep. It's better. What's the answer?
1760.4.
What is part B? What is the stator current? From the circuit, where is the stator current? I'm going to ask you, Zamrani, what is the stator current? Wrong. Is this a transformer? Treat it as a transformer. كأنه transformer. Wrong. That's not that stator. That's the magnetization current. It is I1. So how to get an I1? Do we have transformer ratio? No. So I cannot get E2. Do we have, for an induction machine, a winding ratio? No. I don't know E2, I don't know I2. So what is the only way to calculate I1? Circuit analysis. No. No. You have to find the equivalent impedance seen by the source divided by I1. Then you get I1. So let's do what the equivalent impedance. So this is the source. This is I1. I want to find the box of R equivalent or Z equivalent. What is Z equivalent? Start from right to left. R2 prime S plus JX2.
R2 prime over S.
In parallel with JXM. In parallel with RM. No, in series with R1 plus JX1. This is the fundamental formula. How to do this? By calculator you can do it. And that's why today's lecture is a VIP. So let's call this bracket Z equivalent 1. You agree with me? هذا القوس Z equivalent 1. How to do it by calculator? No, Z equivalent 1 is 1 over R2 prime over S plus JX2 prime. There's a prime I forgot here. Plus 1 over JXM plus 1 over RM and this, صح?
Yes.
Do it by calculator, يلا. 1 over, what is R2? Prime, 0.332 divided by 0.022 plus J times 26.3 plus 1 over J times 26.3. My bad. X2 is not 26. X2 prime is 0.464. Plus 1 over infinity. What is 1 over infinity? 0. So what is the equivalent one? 11.05 plus J 6.7. So what is the equivalent? Add this answer plus R1 plus J times X1. So you should get R equivalent to be 11.7 plus J 6.7. Roughly speaking the same, because these are too small.
I got the J argument to be 7.79. Maybe it's because it's wrong. It's wrong.
Oh, you're right. Okay, what's the final answer?
11.7
Plus 7.7.
plus J 7.8.
Yes.
Yes. So, what is I1? V1 over Z equivalent. What is V1? 460 over جذر 3 angle 0 divided by 11.7 plus J 7.8. So put that 460 divided by square root of 3 divided over 11.7 plus J 7.8. You should get a current of 18.89 angle minus 33.7 amps. So the stator current is this current. 18.89 at an angle minus 33.7 with respect to the source. What is the power factor? Power factor is nothing but you need to calculate. So it's the power factor of the source or the machine is the same. So what is theta V?
0.
So what is power factor? Cosine of? Lagging. Why it's lagging? Because we have an inductive load. As a matter of fact, you can calculate it you can get theta from here, or get theta from the angle of the voltage minus the angle of the current. What's the answer?
0.83.
Clear?
So, معلش كيف أوصل
Because plus J. But theta is what? Theta is plus tan inverse of 7.8 over 11.7.
يعني نشوف الزد equivalent دائما.
Yes, you have to know your load. لأن الكوساين or you can get it from الانجل here. يعني إذا الانجل theta is positive, you know it's lag. This theta is positive, which is plus tan inverse of this. All induction machines should have lag. Inductor. Do you see capacitor here? خلاص lag. Do you see? It's 0.88 lagging. We should never have a capacitive induction machine. Yes.
0.88 or 0.83?
It doesn't matter. 0.833. Who said 0.8? It's wrong. Okay?
الباور فاكتور حيكون نفسه حيكون على اللود ولا حيختلف؟
The power factor will be, the question is the power motor, the power factor of the motor is the power factor of a V and I1 with the whole motor. This is the whole thing is the motor. فالموتر هو اللود.
بس لو جاي يسألني الباور فاكتور حق
الميكانيكال لود.
الميكانيكال ايه؟
This is, you cannot ask what is the power factor of a mechanical load, because a mechanical load will translate into slip. I repeat, this is fundamental equation. Mechanical load will translate into what? Slip. And he did it with omega. Here is how he did it. Now, I have 15 minutes left. Let's start from here. At the beginning, is the input power of the motor larger than the output power?
Yes.
Yes, because we have losses. What is the input power? Square root of 3 Vt. What is Vt? What T stands for what, ya Abdurrahman? Terminal. Is we love line to line or we love? We love line to line. So this Vt in this example is the 460. So you can have square root of 3 460 times I1. What is I? I1. We calculate 18. Times the power factor. What is the power factor? 0.833. So maybe I give you a trick, a question in the exam. What is the input power of the induction machine? You calculate VI1, calculate cosine theta, you already have Vt, you use this equation. Square root of 3 Vt IL cosine theta. So IL is, because it's Y connected, equal to I phase. The first losses is PSCL, stator copper losses. This one, where you think is stator copper losses?
For the area.
Where do you think?
The left side.
Here. The second losses is core losses. Where do you think the core losses? Here. Then we have an air gap power. Why we call it an air gap power? Because here is the border between is primary and secondary. It crosses an air gap. Then we have RCL, rotor copper losses. Here. I square times R2 prime over S. Then induced torque times omega m, which is the converted power. This is the power that is converted into actual mechanical movement. But even if you connect a load, you still have to deal with the friction والwindage. الفريكشن الاحتكاك والwindage الاحتكاك بالرياح. Also you have stray losses or miscellaneous losses, extra losses. Imperfections في aerodynamics والاشياء هذه. Ultimately, is the torque at the load larger or smaller than induced torque? Smaller, because omega m is the same, but P converted is larger than P output. So it means the induced torque is smaller than the load. طبيعي. أنت لما الحين if you have a truck وتسوي towing, is the torque or is the force of the car larger than a load? It has to be larger. سيارة تسحب سطح السطحة لما تسحب السيارة الانديوس تورك يكون في السطحة ولا في السيارة اللي تنسحب؟ في السطح. فالانديوس تورك بيكون في السطح. It has to be larger than التورك اللي يطلع من اللي at the actual car لما يشبك الونش يسحب. Same في الموتور. If you connect the load على electric motor, it has to do with a developed torque. It has to be larger. So when the engineers they design an induction motor, it has to be larger. Do they have the same speed? Yes. البكرة هنا تدور بنفس السرعة البكرة اللي تسحب حقت السطحة نفس سرعة سحب السيارة.
طب التورك حيفرق في ايش اذا كانت السرعة؟
التورك حيصير لارجر لأن في عندك لوسز فريكشن وستري وويندج. السرعة has to be the same. Difference مو difference طبعا difference الجير box. It has to rotate at the same speed. That's why here we have omega m, omega m. So electrical engineers, they do these calculations. Mechanical engineers, they do these calculations in electric vehicles. Here electrical, here mechanical. Here the converter. Clear?
Yes.
There is another way of viewing this curve. Input power, we have air gap, stator losses, copper, core. Then the air gap power, we developed power, we have converted from electrical to mechanical. Then you have the copper losses for rotor. Then we have an actual output power minus the rotation, friction, windage, and strain.
احنا ما عندنا يعني في الموديل حقنا بالنسبه للاير جاب لوسز.
It's incorporated. No, we don't have. We do not have it. We do not have it. The air gap is the core losses minus the stator copper losses. We didn't even include the flux linkage. It's too complicated. The flux leakage, it's usually في الستريت, في miscellaneous. Keep in mind that the induction machine is magnetically coupled very well. لأن الشكل الدائري يقلل من الليكج مو زي المستطيل. الشكل الدائري it will make sure that most of the flux transfer. That's why the induction machine is circular. Why it's circular? ده مو عشان شكله أحسن.
عشان تقلل
انا اللي
عشان تقلل اللوس.
To minimize the losses. A circular shape is the best shape for a motor to spin. What are the mathematical equations for everything? This equation is same as square root of 3 V terminal I line power factor. Do you remember this equation?
Yes.
These two are the same, except one is deal with phase, one will deal with line to line. But we love line to line. It's because it's a three-phase. Every three-phase device, we love line to line. And RMS. This is RMS, this is RMS. And SCL is a 3I1 square R, 3I1 square R1. The core, roughly speaking, they're using this from circuit what? 2. They're saying, okay, let's approximate it to be V over this component from circuit 2, which is a 3, because the 3-phase, V2 over Rm. Do we have 3 in DC machine? No. It's only an induction machine. An air gap is calculated 3 times I2 prime R2 prime over S, which is the torque developed times the synchronous speed. Omega S is synchronous speed. Here omega M. I have to fix it later. Maybe next lecture I'll fix it. This should be omega M. اللي هي الموتور speed. هنا sync. Now we have notations correct. Here we have equal. Here from circuit 2. The converted power, converted is 3I2 square R2 over S times 1 minus S, which is an air gap times 1 minus S. So use this. Don't use this. Use this. And use this. RCL, rotor copper, is SPG. Then the last thing, the rotational, it's usually given in the problem. The output power is torque times omega. So you usually get the power output. You already know your omega m from
The same.
the slip.
2 by n of
No, omega m is from the slip. Or you can get 2 pi over 60 times nm,
and
which you get it from
the slip.
the slip. So that's usually the flow of the design of the machine. You ultimately, what's your variable output?
Torque.
Torque. And now, do you remember what I tell you? The current gives it torque.
Yes.
So push as much current as possible in your machine, you will get highest torque. But conservation of misery. Why? Because if you have so much current, these would heat up, you will have more losses, but most importantly, you might reach saturation in your BH curve. Do you remember BH curve?
Yes.
You don't want to go saturation. If you increase I, you increase H. Is it clear, يا عمر? The power flow, where we get the losses for the induction machine. So next lecture, we will do example number 4. But before we do it, let's study it a little bit. We have 3 minutes left. Example 4, a 480 volt. What is 480? Line to line. 60 hertz, 50 horsepower. Is this input power or output power?
Power.
So what is 50 horsepower in this figure? This one. Okay? How to convert it? Multiply by 746. 746.
6 kilo.
No, this is in watt.
Voltage.
Who said kilo? No, it will be, if you multiply it by 0.7, it will be in kilowatt. 3-phase, IM. What is IM? Induction. The motor is drawing 60 amp. In this figure, where is 60 amp? It's I1, drawing 60 amp. من السبلاي. At power factor 8.5 lagging. Power factor 8.5 lagging. اللي هو هذا. هنا كان 8.3. الستيتر copper losses are 2 kilowatt. When stator copper losses? This one, 2 kilowatt. He already calculated for it. Maybe trick a question in the exam. Stator copper losses 2 kilowatt. Draws current 1. What is R1? Yeah, that's how we make the exams hard. And we will major 2. Major 2 is hard. Very hard. Induction machine will be hard problem. Very long design problem. So you have to read the book. Which book you read? Book 2. Because why? Because I love induction machines. They are very important. Induction machines are more important. DC machines are also important, but the induction machines are more available. So you need to understand them better. What is a rotor copper losses? 700 watt. So for rotor copper losses, it's SPG. I can get the PG if I know an S, if I know PRCL. The friction والwindage 600 وstray negligible معناتها rotational losses is 600 watt. The core losses are 1800. Where is the core losses? The core losses. 1.8 kilowatt. Find the air gap power. What is the air gap power? PG, which is Pn minus this minus that. You have to calculate Pn. This is given, this is given. And it's shown here. You have to get your input power, square root of 3, 480, 60.85, 42 kilowatt, minus the 2 kilowatt, minus the 1.8 kilowatt. Then, what is the power? Power converted, PCOM. PCOM is what? PG minus PRCL. It is what? 38.6 minus a 700 watt. 700 watt high. Then part C, the output power. What is the output power?
مو هو اللي اعطاني اياه الهوستو.
Yes,
يعطوا.
from here. It's 50 horsepower. Or you can get it from 37 minus 600 minus 0. Straight 0. That is the output power. فن انك you map a problem على diagram. If you don't map it, you will not be able to solve it. And since we reached here, the efficiency of the motor. What's the efficiency? Output over input. You have an output, 37.3 over an input. Efficiency is 88, lower than transformer. But still, this is a good engineer. For motors, this is an acceptable value. You cannot have 97 like a transformer. So next time we'll do example 5.
متى الافشنسي اقول انها باد؟ اقل من
8 below 0.8. Next time, inshallah, we'll give you the example. Okay? Please watch the YouTube video. We'll have fake quiz soon, okay? Next week. توفيق إن شاء الله.